Let's go over to the next topic, 3.2 of our textbook, polynomial functions. Let's begin with some lingos. What is a polynomial? This kind of function is called polynomial. an x to the nth power, an minus 1 times x to the n minus first power, an minus 2 times x n minus second power, addition all the way up to a0. That kind of thing is called polynomial. a0, by the way, that can be written as a0 times x to the 0th power, if you will. And then first, this one is x to the first power, if you will. So in any situation, x to the k power always exists. It's just that x to the 0 power is 1, so you don't really have to write it. I think I erased too many. Okay. And I have to start somewhere, so first coefficient should not be 0. Otherwise, this one does not exist because adding 0, and we're going to simply start from here. So that's a natural condition. And there are some terminologies, or rather some lingos that you have to know. Terminology, I'd better avoid that because it's been already taken. ak to the x to the k power is called a term of a polynomial. And well, among those terms, the highest power is often called a leading term, or highest order term, highest degree term, highest power term. There are many names for that. And then this one is going to be obviously the next highest order term. It's not called leading term anymore. The last one, a0, is often called constant term because there's no x there. a1 to the x to the first power is often called linear term because first power function has graph, and the graph of a first power function is a line, so it's linear. And then a2x to the second power is often called quadratic function. a3x to the third power is called cubic term, and so on. And all these ak's are called coefficients. Leading coefficients is an. Okay. So much for the names and lingos, and let's talk about polynomial division. This is division algorithm. P of x divided by d. What do you mean by that? D of x times quotient q of x plus remainder r of x. If you have something like that, then that's division. And there's a rule. The remainder r of x has to have smaller degree, strictly smaller degree than the degree of this divisor. If the remainder has the same degree or even higher degree, then I can keep on dividing by d and then make it smaller. And if I divide everything by d of x, now I'm not going to call this divisor anymore. Now it's called denominator. In that case, we have something like this, and p of x over d of x is kind of like improper fraction where the numerator is bigger. Numerator is higher degree. That's degree of numerator is higher than degree of denominator. That's a kind of equivalent thing for polynomials and rational functions. And then we have a quotient which corresponds to the integer part. And then we have r of x over d of x, where r is the remainder, which has degree smaller than, whose degree is smaller than the degree of d of x, the denominator. This part is proper fraction, kind of like composite fraction. It all follows from the division algorithm. Now, how do you actually divide polynomial? Long division, synthetic division, those are kind of obsolete topic for me, at least at this level. So I'm going to just ask you to read through the textbook. If you understand, fine. If you don't, then you can just resort to computer algebra system the way I do here. You can use this notebook as a kind of template or guide. Mathematica command for getting division done is polynomial quotient command, as I have over here, and then the structure p of x, comma d of x, and then comma x. I have to specify the variable, and then this is the way you get remainder, polynomial remainder command, and then p of x, d of x, comma x, and then running these, I I get the quotient and the quotient and the remainder. So, well, that's much easier and much quicker way to get this division done than using the long division method. Long division method is okay in intermediate algebra level or maybe in college algebra level, but at this level it's just too time consuming and tedious. So I'd much rather advise you to learn to use computer algebra system. Here's another example. It's gonna take a long time if you actually sit down and try to divide by a long division. But if you use polynomial quotient and polynomial remainder commands with Mathematica, and then here we go. What if we do not have Mathematica? Well, you can get this one for free. We talked about it for free. We talked about it in class, and I strongly advise you to get this for free and install it to your computer so that you can use it as long as you're taking a math course. But if you decided not to do that, or I'm simply taking pre-calc and calculus 1 and no more, in that case you can use something like this one. Go to web browser. Let's open up blank screen. Okay. I just ordered pizza, so I have Papa John's there. Okay, and Wolfram Alpha. WolframAlpha.com is the web page that you should remember. This is managed by the makers of Mathematica, and it's basically a free version of Mathematica that handles just single command, something very simple. So for example, if you want to do some polynomial division, here it is. I don't want to rewrite everything, so let me just copy and paste polynomial quotient and something like that, and then let's just copy and paste it over there. Why do I have comma x way back over here? Comma x, okay, and then click equality here, and then it'll do all this division, and then it'll give you the quotient function over here. And this Wolfram Alpha is not as strong as Mathematica, but it is a little bit more tolerant on syntax errors. So if you forget this comma x, I think Wolfram Alpha will accept it and then give you the quotient. Yes, it did. It did. If you do that with Mathematica, even though it is much stronger, it's not going to accept this this syntax. If it has an error, it'll simply spit out an error message. Wolfram Alpha, consequently, is a little bit more user-friendly, and also it is free. There's limitation. It's not as powerful, and you cannot write any program with it. It's just for one single command. How about polynomial remainder? And then it'll calculate polynomial remainder like that. Okay. Obviously it didn't like the lack of comma x there, so let's put that comma x. Let's okay. Okay, the reason wasn't really comma x thing. I misspelled it. Polynomial remainder, and I misspelled it, but still Wolfram Alpha somehow found it and then calculated polynomial remainder, even though I forgot to write m there. If I do it right, then of course it does it more quickly without any error message. You can practice this kind of thing with Wolfram Alpha, and also it'll save you a lot of time. Let's go back to the Mathematica notebook here. Okay, so you can do those kind of division there. Now let's go backward. Let's consider factorization. And factorizations are important. You can always do expansion. You can expand by foiling or whatever through brute force method. But factorization is a lot more tricky. and a lot harder as a matter of fact. And it takes really long time if you have really high degree polynomial. So we use these kind of methods. How do we check if x minus c is a factor or not? We use this thing called remainder theorem. In this division algorithm, plug in x equal to c, then the highlight part here will become c minus c, and that times q of c, that becomes 0, so we have r is equal to p of c. Here's a proof as a matter of fact. P of x equal to x minus c times q of x plus r. Here plug in x equal to c, then c minus c times q of c just disappear because that's 0. And we have p of c equals to r. That's called the remainder theorem. And the special case when r is 0, then it's called factor theorem. When r is 0, there's no remainder, so that means x minus c is a factor of the polynomial p of x, kind of like this. And that's how you can check any target linear polynomial x minus c is a factor of a polynomial p of x or not. And how do you factor a given polynomial? If it's a big polynomial, let me create a polynomial here. Okay, I pause the video and then created a polynomial here. And let's suppose that you have to factor it. And that's not an enviable task. So let me just verbally explain what to do. The first thing you should try is to find out factors of 3. And there can't be that many, 1, -1, 3, and -3, because this is a prime number. And then plug in those values in place of all these x's and see if x minus 3 or x plus 1 or things like those are factors of p of x. If the remainder turns out to be 0, that is p of c is 0, then that means it's a factor. And once you have it, then you can divide this p of x by that x minus 3 or x plus 1 or x minus 1, whatever you found out, and by long division or synthetic division, and then you can get a fourth order polynomial. And then you have to do it over and then get third order, and then do it over to quadratic and so on. That's going to take enormous amount of time. And this is actually exceptionally easier case. If this 3 is not prime, it's composite, then you are considering far bigger, larger number of guesses you're working on. And also, well, we have this factor, so actually considering factors of 3 is not enough. Factors of 3 over factors of 2, also you have to consider all those fractions and plug in all those values. I mean, my goodness, it's gonna take an hour to completely factor this in a traditional method. And I'm not exaggerating. If you actually try that, it's gonna take that long, even for this kind of exceptionally simple problem. But then again, we have computer algebra system here, so let me tell you a very important and useful command that can handle this kind of thing. Instead of using remainder and factor theorem over here, 2.3, use computer algebra system, factor command, and then you can retype everything, but, well, let me take a shortcut. Copy and paste, and then just run it, and then I have a factorization, kind of like this. Now, what if you do not have Mathematica there? You can always go back to your web browser, and then go to Wolfram Alpha, and let's pretend you didn't have that before. So Wolfram Alpha, and then type in factor command, and then you can type in whatever polynomial. Let me save some time. Let's just copy and paste, and then just run this thing, and Wolfram Alpha will factor it. Because this is just one Mathematica command, Wolfram Alpha can handle it. If you have a program that consists of 50 commands, 50 lines or something like that, then Wolfram Alpha cannot handle it. Mathematica can, but Wolfram Alpha cannot. But at your level, this is good.